Hey guys, today we're looking at lesson 5. We're going to graph some proportional relationships. So what we're going to do here basically is we're going to look at the graph of a relationship, and just by looking at it we're going to be able to figure out whether it's a proportional relationship or not. As you can see, it's a pretty heavy vocab lesson here, but good news, you've seen a lot of these words before. So let's review some of them real quick. First and foremost, our coordinate plane. It's basically a grid. So there it is down there. There's a picture of your coordinate plane. We've seen that before. It's what we use to plot points and draw lines and all sorts of shapes, and it tells us a lot of information about what's going on with numbers. Coordinate plane's broken up into 4 quadrants, as you can see from the image there, 1, 2, 3, and 4. You can see where those are labeled. They go in counterclockwise formation. So we have points on our coordinate plane, and they are called ordered pairs. An ordered pair is basically a set of directions on how to get to a specific point on the coordinate plane. So you have 2 directions basically. So just like if you were using Google Maps and it says go down the street and turn left, and then go down 5 miles and turn right and arrive at your destination, same idea here. Our x coordinate is our first set of directions. It responds to the x-axis and tells us how far right or left we should go. And then our y coordinate responds to the y-axis, and that tells us how far up or down we should go. So, taking a look down here, we're going to label some of the missing pieces on our coordinate plane. So they show us the y-axis there, which is our up and down direction. As I said before, I like to think of the phrase y to the sky, since the sky goes straight up, much like our y-axis does. We have our origin, which is our starting point. It's the ordered pair 0, 0. Origin means beginning. That's where you begin when you plot a point. Makes sense. And lastly, we have the x-axis on the left side there, which is our horizontal, which is telling us how far to go to the left or how far to go to the right. So let's fill in some blanks. That first arrow up at the top is pointing at the 1. That is our x coordinate. It's telling us how far left or right we should go from the origin. So we start the origin 0, 0. We go to the right 1 because it is positive 1. All right, I'm going to skip down to this third blank right here. That's pointing at our y coordinate. That tells us how far up or down we should go after we've already gone left or right. So since we have a 2, positive 2 from our x coordinate, which we said was 1, we go up 1, 2 spaces till we get to that point right there. So our directions are done. And as we said before, those directions altogether are called the ordered pair. All right, down at the bottom here, it says graph points 2, 3, and -3, -2 above. Connect the 3 points on the coordinate plane, and we're going to describe it. So 2, 3, so again, we start at our origin. So I'm going to erase that because we don't want to confuse that as one of our ordered pairs. All right, we're going to start at 2, 3. So I'm going to start my origin. I'm going to go to the right 1, 2 for my x. And then I'm going to go up 3 because I have positive 3. 1, 2, 3. And I end up with the right about there. All right, and then we have -3, -2. All right, so now we have negatives. Well, again, we're just going to start our origin. If we're going -3, we're going to go left. 1, 2, 3. And then we're going to go down since it's -2. 1, 2. So I end up with a spot right down here. All right, now it says we're going to connect the 3 points. Now my line's not particularly straight, but you get the idea. All right, and describe the graph. Well, it's a straight line. It looks like a straight line. All right, so in the last section, we looked at proportional and non-proportional relationships. Well, here we're going to figure out another way how to identify if you have a proportional relationship based on the way it looks. So as it says here, another way to determine whether 2 quantities are proportional is to graph the quantities on the coordinate plane. If the graph of the 2 quantities is a straight line through the origin, so let's underline that, straight line through the origin, then the 2 quantities are proportional. So our first example here says the slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane. And then we're going to explain our reasoning. So first thing we're going to do here is we're going to make a table, all right, and we're going to find the following values. And when you do this, sometimes they'll give you some values, but oftentimes you can make up your own because it doesn't really matter as long as it works with the situation presented to you. So I'm going to make this guy a little more chart-ish, if you will. All right. And the first amount of time they give us is 0 minutes. Well, if you have 0 minutes, you're going to go 0 feet. All right. So remember, we said for every 6 feet, it would take 1 minute, or for every 1 minute, it would go 6 feet. So at 1 minute, we'd have 6 feet. At 2 minutes, we'd have 12 feet. At 3 minutes, we would have 18 feet. And at 4 minutes, we would have 24 feet. So there's a nice little handy dandy table that we can use. And here's what we're going to do. We're going to take that table, all right, and we are going to plot that information on our graph. So the most common question I get is, Mr. Downing, how do I know which one goes on the x-axis, which one goes on the y-axis? Well, this one's easy because they label it for you, all right? But what you really want to think about is what we call independent and dependent, all right? The x-axis is always what we call the independent variable. So it doesn't change because the other piece of information or the y-axis change. So in this case, time is not dependent on the amount of feet traveled. All right. So since it is dependent, it is its own thing. It changes no matter what the other variable is doing. It goes on the x-axis. All right. Our distance is what we call our dependent variable. It depends on the amount of time. We don't know how far this sloth has gone unless we know how long it has been moving. So for every 1 minute that travels, its distance changes by 6 feet. So that helps us out. So we can create some ordered pairs. So our first ordered pair would be 0, 0, because at 0 minutes, it goes 0 feet. Our second ordered pair, which we can see created right here, again, time is our x. So 1 minute, 6 feet. So we'll go 1 minute. I'll label these 1, 2, 3, 4, 5, 6. All right, and then our feet will go by 4s just to make it easy on us. 4, 8, 12, 16, 20, 24. All right, that'll work. All right, so we had 1, 6, which is right halfway between there, right, like that. Then we had 2, 12, 2, 12, and then looking back up, we had 3, 18, 1, 2, 3, up to 18, which is right here between 16 and 20. And then we had one more, which was 4 and 24. So we can go to 4 minutes all the way up to 24 feet. So there are all of our points. Well, if we connect all those points, we can see that it creates, not that I drew it that way, but it should create a nice perfectly straight line. And remember, up here we said if the two quantities form a straight line through the origin, then the quantities are proportional. Well, hey, look at that. We got a straight line that's going right through our origin here at 0, 0. So this is, in fact, proportional. Woo. All right, example number 2. It says the cost of renting video games from Games Inc. is shown in the table. Determine whether the cost is proportional to the number of games rented by graphing on the coordinate plane, and explain your reasoning. Okay, so they gave us the chart here. We have the number of games on the left. We have the cost on the right. So 1 game costs $3, 2 games cost $5, 3 games cost $7, and 4 games cost $9. So let's turn that into a graph. All right, so first step, it says write the two quantities as ordered pairs, and they give us our x and our y. So it says the x is the number of games and the y is the cost, which makes sense. The number of games played is not dependent on the cost. The cost changes as the number of games change. So the number of games is your independent variable, or your x, and the cost is your dependent variable, or your y. So our first order pair would be 1, 3. Our second one would be 2, 5. Our third would be 3, 7, and our fourth would be 4, 9, just like so. All right, so step 2 is we're going to graph those ordered pairs. All right, and they made a nice handy dandy graph for us here that looks very nice. The only thing we got to make sure we do is label those. So this axis down here is number of games, and this is our cost in dollars. All right, so our first one, we said one game costs $3, so we go to the right one and up 3. There's our first point. All right, then we go 2 up to 5. Then we go 3 up to 7. And we go 4 all the way up to 9. All right, so let's connect our points and see if we get a straight line that goes through the origin. Well, looks like we have a straight line, doesn't it? But does it go through the origin? No, it does not appear to go through the origin. So therefore, it does not meet both criteria of going through the origin and being a straight line. So this relationship is not proportional. Exclamation. Frowny face. One more example. Number 3. Which batting cage represents a proportional relationship between the number of pitches thrown and the cost? Explain. All right, so we said we could determine whether relationships were proportional if they did two things. All right, number 1 goes through the origin. And number 2 forms a straight line. All right, so let's ask ourselves, do either of these do this? Let's look at softball plus first. So that's our top line here. All right, so question number 1, does it go through the origin? Well, here's our origin down here. Here's softball plus up here. That's going to be a big fat no. So right off the bat, we know softball plus not proportional. All right. So we don't even have to ask ourselves question number 2 because it doesn't matter. It has to be yes for both. So let's look at the fun center. All right, fun center. Does it go through the origin? Well, I'm looking down here. Yep, that goes through the origin. Is it a straight line? I'm looking at this. Looks pretty straight to me. So it looks like we have a straight line that travels through the origin. So fun center is a proportional relationship between the number of pitches and the cost. So you guys have some guided practice you can check out down here. If you have any questions, just go back and check out the previous examples that we did.